So I send my condolences out to all of those who have suffered one way or another from the fires, not just the air pollution, but those who actually lost their homes and or their loved ones. And it's a terrifying experience to be in the path of a wildfire. When I was a child in Eastern Washington, there was a wildfire that got within about 200 feet of our home. It was in the treetops. It seems like a miracle that we even survived. We were in what's called a dry forest zone. And then again, during the Labor Day weekend, my family we were in near the coast in an area that eventually we had to evacuate the home that we were staying for over the long weekend. We would intend to come back in the middle of the week. Uh, and so it's very traumatic for a lot of us, and so these fires are unprecedented in our history, and I think it's worth a look at some of the pieces of this puzzle to understand this a little better. So I've titled this uh, document here, which you have on Moodle, Climate Change, Land Management, and Wildfires. This is a series of remarks and links that hopefully will help us make sense of the horrendous wildfires that either expanded and started in Oregon in the wake of the Labor Day night storm, much of their severity associated with this highly unusual weather event. Almost the same number of megafires, defined as having scorched 100,000 acres or more, were burning last week as have occurred during the entire last century, said Jim Garbash, spokesman for the Oregon Department of Forestry. I got that from the OPB website about a month ago. So the first thing to look at is just kind of have a read of the Oregon story. So that's something that you can click into that gives you a little detail. I'd like you to be familiar with what's in that article. It's brief. It shouldn't take you a lot of time. Take a few key notes or highlight it or print it out or something. So there is an untold story, though, that in this that gets into the whole question of causation a little more. The general debates about fire causation in the West, especially these wildfires, have been along the lines of, to what degree is it a warmer, drier climate, and to what degree is it a lack of good forest management in terms of, for example, keeping the fuel on the forest floors at a modest level, or keeping the small tree and bush density lower, that sort of thing, which requires some kind of labor, of course. And of course, there's always the don't build your house in a forest problem, but there's lots of people that do that too. And so we have all these kinds of risk factors, but largely the kind of public policy debate centers around the climate change question, and which we'll be looking at in some detail, and also the whole forest management question itself. The untold story, though, and this is one that the scientific research community has not yet had time to weigh in on, is what's going on. Excuse me. Is that something extraordinary happened with the weather? And it was part of a larger pattern of high amplitude waves and blocking patterns in the polar jet stream, something that has been getting more extreme in recent decades. And this high amplitude waves and blocking patterns in the polar jet stream is likely driven by the warming Arctic. What I'm referring to is the big windstorm that started on Labor Day and blew fiercely into the night and all through the next day, and still was blowing fairly hard out on the west parts of our region, even on Wednesday. So there is a document for you to look at in Moodle titled Arctic High in September. But what I want to do first is just link into a descriptor of the polar jet stream terminology, just a tiny bit to understand where we're at with this. And what I'm going to do is come down to look at what the meteorologists call a Rex block. And what we had was something kind of like this. In fact, that's what they called it. It was called a Rex block. And these have become more common when in recent decades with the Arctic being warmer. It's conducive for these high amplitude waves like this that do this kind of motion rather than lower amplitude waves or straighter kind of what's called zonal patterns. And when we, in a moment, read little parts of the National Weather Service description of what was setting up in this storm, when they mention a Rex block, this is that one of the unusual patterns that we're seeing more and more of in our weather. Those same Rex blocks have created very slow-moving activity of tropical storms and hurricanes focusing on this part of the country. And when a hurricane moves at 1 or 2 miles an hour with 150-mile-an-hour winds or 100-mile-an-hour winds, whatever they are, and rainfall, it just keeps raining and raining and raining. So you might remember near Houston, Texas, a few summers ago, they literally received in some areas 60 inches of rain. That's part of the warming Arctic story too. But ours is more about a particular unusually strong wind pattern, a very dry wind, a very hot wind, one that is basically unprecedented in September in our recorded history here in the Pacific Northwest. Here's a look at a little bit of the language used by the National Weather Service. I've been reading National Weather Service forecast discussions on a fairly regular basis. They come out every day, and I've been reading these really since the 1980s and onward, given that I've been in wind sports since I was very young, kind of typical college student age. And so a couple little things. So here's the discussion. This was on Sunday in the morning, the day before the storm. They've been talking about this since I think about Wednesday of that previous week, and their forecasting was just right on the money. It was kind of amazing. A potentially historic early September east wind event is on its way towards southwest Washington and northwest Oregon Monday night and Tuesday. Okay, so just a little bit on that. And then and there's a bunch of descriptions of what's going on with the dynamics, but I just kind of zoomed up into the big print here for stuff to give you the language of how extraordinary this really is. Looking at the big picture, the long wave upper level pattern is beginning to amplify over the Pacific as a very strong upper level ridge noses north toward Alaska. This upper ridge is presently a sprawling area of 500 millibar heights above, anyway, without getting into the technical parts of that. Here we are. The westerly portion of this upper ridge had already been displaced northward as part of a Rex block with the dry upper low to its south in the general vicinity of 135 north, 135 north, 135 west. Further west, a vigorous upper low south of the Aleutians is becoming part of an amplifying upper trough jet stream from the Kamchatka Peninsula, that's in eastern Siberia, by the way, digs into its west side. This amplifying pattern is something we often look for to diagnose winter Arctic high pressure systems digging down through western Canada into the interior northwest. These systems are often responsible for our winter cold east wind events, with strong high pressure establishing east of the Cascades and driving strong east winds through the Columbia Gorge and occasionally downslope winds spilling over the Cascade crest if the cold pool is deep enough. Okay, and you've heard a little bit about that already if you've kind of been following in the class with the reading in Clifford, Mass, and so on. Well, it appears that the atmosphere hasn't looked at the calendar because models show excellent agreement that this overall setup will occur Monday and Tuesday, resulting in a potentially historic east wind event. September Arctic high pressure squares off against a very strong inverted pressure trough along the coast, which is strengthening as exceptionally hot weather over California expands northward. Here's the statement that's really kind of amazing. The next section here. This is probably as close to a continental style class of the air mass as we can get, especially in early September. I'm going to skip down now and show you a little bit about that. There are many concerns regarding this event. Chief among them is the extreme fire danger that results from desiccating offshore winds of near record strength for late summer. Since this forecast, this is basically a guidance term here. Since this forecast is ridiculously long and late, what happened was, I'm sure that they were discussing this at great length in the weather office, and were just kind of scratching their heads as well. And it was probably very stressful because they didn't really know how strong a statement to make because they'd never seen anything like this before. I won't get into the weeds regarding specific except for one. Just after midnight Monday night, the 6 Zulu NAM continues to show two rather broad maximum of 70 to 80 knot east winds, extending down to 900 millibars. Okay, so that's just up in the atmosphere, a few thousand feet above the surface. Over the western portions of the Columbia Gorge, blah, blah, blah. Okay, this magnitude would be worth a high-end east wind event at any time during the year. And so what they end up talking about later on, and I am just wanting to make sure I find this for you, is how extraordinarily unusual this event is. Let's see here. I think I skipped over it, didn't I? Oh, there it is. Yeah, I skipped over it. Okay, so here we are. The easterly wind component of both models are in the neighborhood of 7 to 8 standardized anomalies for this time of year. What does that mean? That means that the probabilities of something ever happening based on any of the recorded history that the National Weather Service models have for a late August, mid-September event like this are as close to zero as you can get without being zero. That's 8 standard deviations. If you had a statistics class, you know, by the time you get to about 4 standard deviations, it's less than a 1% probability or once in a century. This is 8 standard deviations. It's so far off the curve that it's just unbelievable, okay? So this was an event of no precedent at all for this time of year. It was just hard for them to even conceive of what was going on. I'd read some of the earlier discussions about this on Thursday and Friday before the Sunday one and Saturday, and it was really, really interesting. So what I'm telling you is these are different times. This is not the same climate that we had when I was born or even that you were born with. This is something very different, most likely, extremely unlikely that we're really looking at the same dynamics. That's how I would say it in a probabilistic way. Okay, so that's just a little bit about that weather statement. Now let's go back to our little handout here. I think I'm probably, yeah, I got about a minute and a half, okay, on this video. So talk about this here, and then what I'm going to do is go ahead and cut this off. We'll do the next video on this next part of the hour. Okay.